Okay guys, I just finished making this video and I thought it needs a little explanation at the beginning. What I'm going to do is I'm going to build a 36-inch color VECTREX arcade machine, and this is just a bunch of video of my adventures along the way. I'm going to do a lot of experimenting and we'll see what happens. But also, I mentioned at the end that I'm going to show you schematics. Don't hold up for that. I'm going to show you schematics on video too. But yeah, so let's start the video. What's going on, guys? I put a lot of thought into what I'm going to use the 36-inch color vector monitor for, and I thought about it, and you know what, the Vector ZVG that I hooked it up to in the last video, it's really cool, but it just doesn't feel right. It bothers me that it's not a real arcade machine. It's not real arcade hardware, and I don't know, it bothers me. It feels like an imposter in the arcade room. So I'm going to make I'm going to put it in a cabinet in the future. It's going to be a 36-inch VECTREX, color VECTREX cabinet. So VECTREX won on the war on that. I mean, I was kind of throwing it back and forth. I really didn't know. And plus, I asked you guys, and you left some comments, and no one suggested the Vector. You guys suggested color VECTREX, so that's what I'm going to do. Oh wait, someone did say Tempest. That is cool. I thought of that myself, a giant Tempest. But okay, so this is what I'm going to do. Right now, I currently have my VECTREX tore apart, a million pieces right now, because I'm waiting for the right television set to steal parts from to do the color modification. The VECTREX is going to be my regular VECTREX is going to be a color VECTREX, color screen and all. And so I do happen to have this board right here that someone gave me on Facebook. I actually put on Facebook, I says, hey, does anybody have a spare VECTREX board that I can experiment with? And somebody gave it to me, didn't even gave me free stuff in the box, but extras, but didn't want me to pay him or nothing. So I really appreciate that. But so all right, since I'm not going to have a VECTREX in the cabinet. First off, I don't like the VECTREX in the cabinet because I can't mess with it. Second off, it's just kind of sitting there. It's right, and, you can't move the cabinet unless you take everything apart. I just don't like it. So I'm going to mount a VECTREX board onto a piece of wood, and I'm going to do like the buzz-off kit, like my own homemade version of it, and whatever. But I can't have, see right here, let me pull this out. This is the current look of my VECTREX. Right now, the board you're looking at is the power supply and deflection board, okay? And I don't want that. First off, I need it in my VECTREX. And second off, it's just a big hulking monster that does extra things that I don't need. See, the deflection board that I'm going to be using will be built into the 36-inch monitor, so I do not need a deflection board. The only thing I'm missing here is power and sound. So I'm going to make a simple circuit using, I'd laid out some regulators here and some full wave rectifiers and so on, but I'm going to make a simple circuit. Let me move this out of the way a little bit. Right here. Let me zoom in. Can you guys see that? It's a little washed out in the camera. But basically, I'm going to use a transformer. I have a spare VECTREX transformer. No VECTREXs were harmed during the making of this video. It did not come out of a working VECTREX, something like that. But I'm going to have the center tap, and it's going to and two AC lines. And I believe, I really don't know. I didn't look at the schematics, but it's probably somewhere around 15 to 18 volts. That's my guess. Whatever it is, it'll be okay. But it's going to go through a Wheaton bridged rectifier, a full wave rectifier, and then through a couple filter caps, and I'm going to use a 7915, and I'm going to use a couple diodes to drop down to negative 13 volts and so on. But if you guys want to make your own, I have not built this yet, but I know this will work. Although the 7805, the regulator I'm using is rated for 1.5 amp. That may not be enough, so I'm going to have to actually measure the load on the VECTREX to see what it takes. This isn't always a good idea, but I may actually put another 7805 over top of it. I have seen arcade circuit boards. They did that, but really it's kind of a bad idea. But that may be the route I'm going. So in other words, let me see. Where's my pen? So I may actually have another 7805, just like that. Now that would bring me up to 3 amps, and I'm sure 3 amps is good. The 1.5 amp is questionable. Also, by the way, not all 7805s are created equal. The 7805C is 1.5 amp. The standard 7805 is 1 amp. And yeah, so basically some filter caps coming in, some filter caps coming out, and I'll have all my voltages required to run the VECTREX. I'm going to try to fit it on this little tiny piece of perf board. I don't know if I can fit it all on there, but anyway, so I'm going to mount all this stuff to this board right here, this piece of wood, and see where I can fit it all. So let me build this. Power supply. If this works, which I'm certain it will. These are some schematics. You can build your own power supply for a VECTREX. But all right, so let me start building this thing. Oh, you know what? There's one more thing I wanted to mention. The color. Let me move this thing over. Now I have tried different methods to colorize the VECTREX, and I went back to the original design. You know what? This is so simple and stupid, but I like it the most, and I'll tell you why. See, I tried latching data and so on, and I tried a lot of different ways to go about it, but I kind of like the simple or and circuit. And the reason why is because there is obviously there is not any color data coming out of the VECTREX. So I kind of like the haphazard random way that this draws it. I mean, you know, certain games it looks great, but when I try other methods like latching the data and so on, it makes things look a little off. So I prefer the look of this instead. And so what I'm going to do is now this design right here does not allow for color intensity. Okay, so you have 8 solid colors and 0 levels of intensity. So in other words, when I say intensity, I'm talking about how bright is that vector beam. And so I believe the original VECTREX has 32 levels of color intensity, and I want to keep that. And I'm going to do this in a haphazard way, but it should work. I'm going to get 3 little transistors like this, and the Z is going, the Z out, the normal Z out for your VECTREX is going to give the power to these 3, I have 2 in my hand, but these 3 transistors. And the when I get a signal to the base of these transistors, that will turn on the intensity. And depending how much power is given to these transistors from the Z intensity, I will have my colors. So, in other words, this will, in a half digital, half analog sort of way, this will give me 256 possible colors. And if I may not like that, because I tried 256 colors with different methods, and it's I didn't like it so much. I kind of like the standard 8 colors. It looked better, in my opinion. But we're going to try it this way. If not, I will remove the intensity levels entirely, like before. But I kind of want the intensity levels there, don't you? So, okay, in the end of this video, I will show you. See, oh, also what I'm going to do is I'm going to get another piece of perf board and get this whole circuit and put it on its own board, and it'll be like a permanent solution, a permanent thing, you know. So, okay, let me go ahead and build this stuff, and I'll show you guys what I did, and in the end of the video, I'll show you exactly how to do it all. Okay, so I have it all put together here. This is the power supply board that I made here, and here's a couple of filter caps. Here's the bottom of it, you know. And I went ahead and tested the voltages, and I have exact dead-on voltages. Well, I have a dead-on -5, dead-on +5, and my 13, which is originally unregulated, my 13 volt is regulated at 13.4, so that's good enough for me. Yeah, I know this is This is made from stuff that's just, you know, I have laying around. I mean, these two big filter caps is overkill. But why not? Why not filter it out better than original? Yeah, so this is actually better than the original VECTREX power supply. But so yeah, so that's going to go something like that and whatever. Well, anyway, so right now I'm going to put this together, get this amp hooked up. Now, I have not looked into how they do the buzz-off mod or whatever they call it, buzz-off kit. But what I noticed, and I'm not looking at the schematics either, but what I noticed is this originally had a 10 kilo ohm potentiometer across here for volume. So I got a 10 kilo ohm resistor. Now, I may not even need this, but just because, I'm going to put it here. I'm going to put it across right here as if there's a potentiometer. Okay, let me zoom in a little bit. Okay, and where'd my soldering iron go? Just gonna do I can't get close to it because the camera's in my face, so I'm doing this at a long distance here, but I may not even need this, but I might as well emulate the original circuit. So, what are my cutters? That looks like crap, don't it? Let me just clean it up a little bit in the bottom. Yeah, good enough. Okay, so that's rigged up. I don't know if it needs to be slightly tied to ground or not, but you know, that's how I'm doing it. So it looks like I just have ground and this, and that's gonna be my input for the new amplifier. So let me get some, I'll go ahead and wire this up. Okay, so I have this soldered on both sides of this resistor. Now basically this is going to simulate or be the same thing as if I turn the volume all the way up. Okay, and see here, right here's my audio amp, and it wants an input from a 3.5 millimeter jack, but we're not going to do that. See here, this looks like it's ground, so let's tie that into ground. Grab my soldering iron. Okay, there's my ground, and this looks like it's a audio in. Now honestly, I'm not worried about shielding this, because unlike in the original VECTREX, it's not next to a giant chattering monitor, so I'm not worried about shielding. I will get no buzz. Also, the schematics. Let me grab that schematic. This was just a guesstimate on what I should do, and you know what? It's definitely overkill, but that's okay. Yeah, I got some flux on the paper here, but definitely overkill. But so what? So what? I put these. See, these two capacitors right here are the two big capacitors on the power supply, and I originally thought smaller, and just for giggles, I went back and I looked at the VECTREX schematics, and it called for a total of 20,000 microfarad on the 5-volt line and 10,000 microfarad on the negative 5-volt line. So that was pretty crazy. That's pretty big. So just because I put two 2700 microfarads, because this is what I had laying around. These are actually Atari Big Blue capacitors, the ones that are bottom of an Atari, like Asteroids or Centipede or whatever. And yeah, so that's way over filtering, but so what? It's what I have. It's what I'm laying around. By the way, these diodes I put in are 4004 diodes. All the diodes in this circuit are 4004. And I did go ahead and double the 7805. I've seen it done before on mass-produced things. I mean, I know some people don't like to do that, but I know it works. Yeah, and you know what? These two caps are the ones that really matter, and these two, just I don't know, put whatever you want. Put whatever you want in there, whatever feels right. But yeah, so let me hook this thing up, and let's see if we get a screen. Oh, I gotta hook up power to the audio amp, but you know, that's all. Good enough. I'm not here to win any beauty contests. As long as this thing works, that's all that matters. And it's dependable and so forth. Okay, there's my power to that. Okay, so now I have everything mounted. And yes, this is electrical tape. I don't care. Okay, so I got the audio amplifier right here. I'm going to turn it up somewhere in the middle here, and all I have to do now is just plug in the power. See if we get that tone or not. That's what I wanted to hear. No buzz. Perfect. Well, now I guess I'm gonna have to make the color mod, and I'll mount it somewhere up here, and then I'll you know, put it back inside the arcade cabinet. And someday in the future, I don't know when, but someday I'm gonna have to pick a whole different cabinet in order to fit the what's it called? In order to fit the 36-inch monitor. So let's see where we go from here. Well, fail. We got ourselves a fail. After it runs for, I don't know, about a minute or so, 30 seconds to a minute even, the 5-volt regulators get hot, and they go into like a shutdown mode, which is actually a built-in feature on the 7805. So this is garbage. So what I'm going to do is, I have this little thin client computer, and I'm gonna see. I don't know. Some of these have negative. Some of these, all right. There's a computer power supply. I may use this instead. And some of them on the newer machines, they eliminated the -5 voltage. So, and some, actually, I don't know for sure. Some of them may actually have -12, I think. So, let's see if I can get this. Oh, and my batteries fall out. So I'm gonna see if I can reuse this. That's a little better. Okay, so let's turn this on. Where's my power plug? Fail. Okay, we're plugged in. Hit the power button. There's no RAM in it. Okay. As long as it turns on, I don't care. So I'm going to hit this to ground, and this should be my +5. Yep. And yellow should be 12. Yep. And green is usually what switches it on. Nothing. Okay. Black are probably all ground. And we have -12. So we have +5. Did I have -5? No, I did not. I did not have -5. So this what I'm going to do. I had no issues with the 7905 in that circuit. Let me turn this damn thing off. Okay. I can substitute the -12 for the negative 13 on the VECTREX. So I'm going to go ahead and use this power supply instead, and I'm going to run 179.05 off the negative 12 volt line, and that should give me all the voltages I need. Man, this turned into a nightmare. This should have been good to go, done. I didn't expect the VECTREX to pull that much current on the 5 volt line. Interesting. But, damn. So I just basically wasted like 45 minutes to build that stupid board, and I mean, I suppose I could rip this crap off. I suppose I could add another transistor, like a 3055 or something like that, and have the 5 volt, the 7805 control the larger transistor, like in most arcade power supplies. But I thought the VECTREX would draw so little power that it wouldn't be such a big deal. Oh well. We'll use this. This is a nice clean switcher anyways. Alright, let me pull this thing out. Okay, I did a temporary job here wiring up this power supply. Now I did not have negative 5, so I ran a temporary rig job right here, a 7905, running off the negative 12 line to power my negative 5 over here. Well, I find another roadblock. I mean, it may be, I don't know. This sticker right here says the negative 12 volt is only 100 milliamp, so I don't know, that may not be enough. That may not cut it. So I'm going to test it right now. I got it all wired up. I'm going to turn it on and see what happens. It did turn on, but I'm curious. Let's see what kind of voltages we're going to get off of this. For all I know, negative 12 is dead ground for all I know. Let's see here. Here's a good ground right there. Just going to pull it off of here. Here's my negative 12. It truly is negative 12. Negative 5 is truly negative 5. Well, I guess it doesn't need that much power. So, I guess I'll screw this sucker down. But man, that still pisses me off. I was convinced this stupid schematic was going to work. So, let me think of a more permanent. I may actually, since this takes so little juice, to run on the negative 5 and the negative 12 line, I may just put some heat shrink tube around this sucker and tape it up and kind of like hide it in the harness. I don't care, as long as the sucker works. Alright. Well, I went upstairs and I watched an episode of Family Guy to kill some time, and it's been running this whole time. So evidently that 100 milliamp was enough on the negative 12 volt line to keep this running. I retested the voltages; they are still good, and I did like a half-ass electrical tape job here, and heat shrinked all around the 3 leads on the 7905 regulator. It's not the best thing to do, but it's gonna work just fine. So yeah, so now I gotta build a color board. Alright, well, I built this. Get this out. This is the same part I used from the breadboard model, or whatever you want to call it. And this is the finished ordeal. Got 3 3904 transistors that are actually going to be adjusted by the voltage by the Z intensity, of course, like I said before. And I still have my 8 bits of data on the input right here. And I'm going to put them actually going to have my wife. My wife wanted to do it, to put the 8 bits of data going to the data bus. Now, you don't have to have it in a specific order. This is just for color preferences. So I'm going to have her go ahead and test and plug in these wires right here. And this right here will go to like a chip select on the VECTREX. So I'll wire that in. Before I had it as a test, I hooked up to the Z intensity. Well, now I'm going to be using the Z intensity to drive the 3 color intensities. So this is going to actually go to a real TTL chip select this time, like it should have in the first place, to be honest. But yeah, so there's the bottom. I know it's kind of a shit slapped together kind of deal, but as long as it works, I'm okay with it. So I have to look up on the schematic which pin is chip select on the VECTREX and solder 1 wire to it. I printed this out. Maybe this will help you guys. Let's see here. The 2 chips I'm using right here is, let's see if I can get a good picture of it. So 74LS32 and a 74LS08. Now, this is a quad OR gate. This is a quad NAND gate. Really simple. I mean, this is super simple, but if you don't understand what this is, I'll explain it, okay? Let's say you have 1, 2, 3, 4, 5, 6, 7, 8 lines of data. What that means is, I'm going to say this as simple as possible so some of you guys can understand. This is an easy way to learn some simple stuff, because this is really simple. Okay. But 1 through 8. Each of these numbers stands for a wire. So you have 8 wires coming in. Okay. And each wire, you can call it a bit. You know what I mean? I'm going to say this simple now. Like, let's say you have something that has 8 bits of data. Well, everyone's heard that term before, but do you understand that it's literally just a wire? That you see 8 wires, you know, so there's 8 wires that can have ones or zeros, in other words. And so what I'm doing is, with an artistic, not a technical, an artistic, my wife is going to do it kind of thought. You get each of these OR gates, and we're going to put a bit to each OR gate. So this might go to 1, and this might go to 6, or this input might go to 5, or this input might go to 3, okay? And the way an OR gate works is, right here's an OR gate, and my terrible drawing skills. Okay, now the way an OR gate works is, either this input can be a 1 to turn on this input, this output, or this input can be a 1 to turn on this input. So in other words, as long as one of these 2 wires is on, the output wire will be on. That's all that means. So basically, this is getting your 8 bits of data and tying it into 4 bits, 4 wires left, because it OR'd a whole bunch of those 2 together. So now we only have 4 wires left. Okay. Now, then we connect this chip directly up to the quad AND gate. Now the AND gate is very similar to an OR gate, but this input needs to be a 1, and this input needs to be a 1 for the output to be a 1. So that's all that is. Now, so the remaining 4 wires are coming from this 74LS32 and going to the inputs of the 74LS08. And the way we're doing that is, one of these wires goes to each goes to 1 pin on the inputs on each AND gate. Now the other pin on the AND gate, so in other words, let's say the chip only has 2 AND gates. It has 4, but multiply this idea by 2. Okay, 2 of these inputs are tied together. So in other words, all of one of the inputs are all tied together across this whole chip. And that tied together wire for me is right here. This is tied to every single input on the AND gate, and this is going to like a chip select on the VECTREX. Does this make sense? So now you may have already noticed, wait a minute, I have 4 outputs, and there's only 3 colors, 3 possible colors, right? Well, that goes into where my wife's thoughts of where she's going to put the these 8 bits of data. Now, we know we have 8 bits of data, 8 wires, but the way they're numbered is the higher number is the most significant bit, and the lower number is the least significant bit. And so what we're going to do is, let's say here's my AND gate, and here's an output, and here's an output, and we're literally going to bridge those together. That way we have 1, 2, red, green, for example, blue. Those are going to be our colors. This is not the most technical way, but after doing a lot of experimenting, this is the way I like it best on the screen. You know what I mean? So the idea is to try to select my bits in a certain way, so red, green, and blue get about the same amount of output. Because I mean, I could mess this up. I could put all the most significant bits on the blue, and then have both AND gates tied together and have like the screen be 90% blue. So it's got to be like a balance between how this is wired, and that's where I'm just kind of gonna trust my wife to wire it in. And because see what I did is I tore apart a machine pin socket right here, and that way my wife can just you know, stick these in like that, and then pull it out and swap it around. Then whenever she finds whichever way she likes it, then I'm just going to solder it in permanently. And at the end of this video, I'm going to show you an actual schematic of what this is actually going to be. Now, these 3 color transistors. Let me show you what I'm doing here. I haven't tested any of this yet. You are watching this right here with me. I have no clue if this is going to work yet. Well, I know this part's going to work, but with the color transistor thing, it probably will. But okay, so there's 3 circuits that are repeated, and it's a. Hold on, let me draw it. Okay, now we have a 3904. Where am I? Oh, I'm not even in the screen. This is a 3904 transistor. Okay, and I'm putting a 470 ohm resistor right here, and this is tied directly to ground. Okay, and this is going directly to how did I do it? Yeah, I did it that way. Right? Yeah. This is going directly to plus 5 volts. And this, the base of the transistor, is going directly to my colors. Okay? And the way this is going to work is my voltage right here, my plus 5, isn't really plus 5. The way I'm thinking is I'm going to connect this. See, okay, this circuit will be repeated. Let's do it this way. Ah, jeez. I am not an artist in any way, shape, or form. Okay, I only copied this circuit twice, but let's just pretend it's 3, just for ease of me, if I can spare you for my terrible drawings. Okay, so normally this would be, if you had a normal transistor circuit, this would be tied to a solid voltage. Okay, but instead, this, all three of these transistors will be tied to the VECTREX Z output. Okay, so instead of, see, normally if this was high, it would switch this transistor on, and the output, oh, did I show you the output? Okay, hold on. Right here would be the output. Let's say this is green, and let's say this is blue. Does that make sense? So green would come in. If the VECTREX called for green, it would trigger this base, which would then deliver this voltage to the green. Okay, but I want to keep all 32 levels of intensity. And this is a really cheap, shitty way to do this, but I think it may work just fine at the same time. Well, like I said, I'm testing it just right here along with you. So anyways, when this calls for green, this will only give as much voltage as the Z output can deliver at that specific time. So when this says I want green, the VECTREX, when in black and white mode, might say, oh, that is full intensity. Or it might say, this is very low intensity. And there's 32 levels between all the way on and all the way off that this green can be when the VECTREX calls for green. Does that make sense? So 32 times 8 is 256 colors. So I hope that didn't bore you. I tried to make that really super stupid simple. And if you didn't understand that, and if this works, I'll send you. I'll put a real schematic on the bottom, at the end of the video, so you guys can build one yourself. I'd really like, more people to build these, because I hope someday that this is actually not a good method for a programmer to utilize, because although a programmer can utilize some of it, but it's really not. You need to put some latches and stuff like that in there. But since no programmer ever wrote color software for the VECTREX, I think this is the best method to randomly pull up data. But I don't know. We'll see. Let's put this damn thing together and let's quit jabbering, right? Okay, so my goofy little wire up deal right here. It's bugging me. It's bothering the shit out of me. So I'm just gonna do it right. I know I could probably get away with it, but I'm just gonna do it right. Now this is my DAC. Not the best way to take off a chip either. This is my DAC. Yeah. And what I'm gonna do, let's put this in my already made socket deal right here, where I can pull off the 8 lines of data. I'm going to put this in here. Okay. And I'm going to put this right here. Okay. So now, nothing was actually removed from the circuit. The VECTREX circuit is identical, has not changed. But I did pull some extra data off it with this ribbon cable going to here. So let me put this together. Hopefully this works. I mean, I could have screwed up a number of things on here, but let's hook this up to an actual color monitor. Now, if you don't already know, I have not done a VECTREX mod for the 6100 monitor. Now, my 6100 monitor is far from stock, and maybe in the future I'll show you a video on how I made my 6100 more like an Ampliphone and so on. But the 6100's input voltages is much closer to a VECTREX output voltages than, say, a 19V2000 black and white or a 80 or a G05 802. So the 6100 does not require any modifications to get a picture from the VECTREX. So, but of course, instead of a full screen, you get a screen like that, much smaller. But it's still good enough for testing purposes, so I don't have to mess with the monitor circuitry yet. Also, if I really wanted to, I could, I suppose, put some op amps in here to match that voltage, but it's going to be easier just to cut some resistors here and there. You know, this is the first kind of video like this that I'm doing where I'm actually, you know, I had some of you guys say, well, hey, can you go into depth? Well, I'm going to go in depth here, but I'm just experimenting. I mean, well, I don't know. I hope this video goes well in the end. We'll we'll find out. See, that's why I didn't want. I didn't know if I was rambling on too long in videos. So this is kind of an experiment video where, you know, let's have Jason ramble. You know, but okay. So let me get my wife down here, and she's gonna put this bullshit together. Well, I hooked it up, and it's not working. The Z drive for all three colors will not shut off. I feel like smashing this thing. I'm kind of pissed off. So I have my wife, who is more patient than me, and I drew up some really crude schematics and haven't heard trace out what I wired wrong. I wired something wrong here. So hopefully in a few seconds you'll see it working. But I'm about ready to smash this damn thing. Check this out. We checked everything out and everything's working fine. Perfectly fine, right? Well, I printed this out from the internet and it's a goofy fucking pinout. It's wrong. I'll show you what I mean. Here's a different one. Okay, and you see how the gate's pointing down right here? Same chip. Alright? Well, this one's pointing up. Somebody, when they made this pinout and put it online, they put this whole gate in backwards. So I actually wired everything right. So I'm gonna have to rewire this damn thing because this section is actually incorrect. Well, let's do it. Damn, that pisses me off. How often? I mean, I had it before, but how often do you get a wrong fucking pinout? Okay, so it's back together. It's actually working. There's some missing colors, but I think I need to do a little bit of hacking, you know, a little bit of tweaking, but we'll get that. I can see there's some missing information from here to draw this side here and so on. But I'll figure that out. But the original Wells Gardner 6100, there must be a pull-down resistor on each color or each Z amplifier, because it's pulling down my 3 transistors pretty hard. In fact, the only way, you're looking at 8 color mode right now, the only way I was able to get more colors was to put a MOSFET and have that run off the Z amp, which was then pumping 12 volts into my little transistors. So I believe this monitor is pulling down my Z really, really hard. So I'm probably see, I got some colors missing here. Although, hold on, I had it. I just gotta wiggle something and solder correctly. But anyways, so I think I'm going to, from here, I'm just going to take apart the 6100 and I'm going to convert it so it will work better with the VECTREX. So that's what I'll do. Okay, I modified the circuit on the 6100 monitor, and R600 and R700 on the deflection board, I I replaced those, or I put a 470 ohm resistor over top of the existing resistor. Also R601 and R701, I cut both of those. And on the neck board, R503, R505, and R501, I replaced the 1 kilo ohm resistor with all 3 of those with 2.2 kilo ohm resistors. That is now has less of a pull on my transistor circuit for the colors. And I've tried a few different colors now and a few different games now, and I see lots of colors. I don't know if I have 256 colors out of this, but honestly, there's a lot of browns and skin tones and pink and different kinds of orange, and a lot of the colors are dim, and I don't like it. Not you know, I'm going back to 8 colors. I know it sounds bad, but at least when it was just 8 colors, it was bright, loud colors. Instead of, you know, some of this are just really so dim you could barely see it. Oh, by the way, on the beginning screen, remember how the sides weren't there? That was the color that couldn't be displayed because it was being grounded out so much. So honestly, yeah, see how this is there? How dim that is? That was just a really, really dark green that, you know, it couldn't be displayed because it was being grounded. Honestly, I don't like the goofy colors. I'm gonna go back to the loud colors. And so pay attention to this because the next picture you're gonna see is 8 color mode. Okay, this is 8 colors. Can you tell the difference? I can in person for sure. You know what? Let me turn the VECTREX off and on. Oh. Also, I have a bad ground right now, so. See, I have a yellow here, purple, cayenne, green, yellow, light blue. But you know what? I like it 8 colors. I still gotta mess with these colors. Also, you notice the picture is larger. It's about 50% of the screen right now. So, you know what? I think I'm going to change the capacitor sizes on the VECTREX board to enlarge the picture the rest of the way. I could squeeze maybe another 10% out of this monitor, but I'd rather just increase the signal output on the VECTREX itself for the rest. But yeah, I'm gonna call it. This is gonna be. I'm gonna make this a 2-parter because this is going nuts. I'm going to call this video building the color VECTREX step by step or something like that. This is just me experimenting here. I mean, you know, I'm no electrical genius here. I'm just interested in this. But alright guys, if you like what you see, please leave a comment down below. Please give me one of these. Give me any comments on all the things that I did wrong in this video. I want to hear it because I know I did a lot wrong. But alright, have a good one.